Hello, everyone. What you're looking at right now is a 6502 based computer. Now, as you can see, looking at these, I don't have any RAM or ROM set up quite yet. It's because I have the 6502 set up for free running mode. So, zooming in on our components, I have the 6502 right here. I have a little reset circuit. So this is power on reset, little reset button. And then I have a 1.6 hertz oscillator. Now, that's kind of slow for a computer, considering that the 6502 can run at megahertz speeds. But there's a reason for that. I want to be able to see what's going on with my circuit currently for troubleshooting purposes. Now, in free running mode, the 6502 is tied down. The data lines are tied down to the NOP command, or no operation. You can see that I have my address lines hooked up to these LEDs. The LEDs should display the current address that the 6502 is connected to. And then I also have some LEDs just showing some basic cycle time outputs. So for example, this is showing that my oscillator is working, and then I have the oscillator is hooked up to the phase 2 clock on the 6502, and this LED is hooked up to the phase 2 output, and this LED is hooked up to the phase 1 output. So we should see them alternate between them. And I also have an LED indicating that my reset circuit is working. Now let's go ahead and turn this on and see what it does. Cool. So you can see right now that it just flashed through a series of LED blinks. Now what that was doing was it was jumping out to some of our vectors, namely the reset vector. So the reset vector, it exists in the FF page of the 6502's memory. The reset vector, what that does is stores the address for where to start executing your program from. Now, when it went to the reset vector, it read the data lines. Now, if you recall, the data lines are tied down to the NOP command. So, the hexadecimal representation of the NOP command is EA. So the address that the 6502 read when it jumped to the reset vector was EA. So it started executing our quote-unquote program from address EA, since it read in the low byte and the low byte then the high byte. It's a little Endian processor. Now what you can see what it's doing right now is it's just cycling through different addresses. So it's currently the EB register, and you can see that by this high byte for our address lines. It is 110, 1010, well, 1011, which is E and then B in hexadecimal. And then you can see that it's just kind of cycling through these addresses. And every time that it gets to a new address, it just reads the NOP command, so it doesn't execute anything. And in free running mode, it's just going to continue that infinitely. So it's going to count up through all the addresses from EA to FFFF, and then wrap around and start executing from the 0 page. Now if we zoom in here, we can see that I have my alternating LEDs blinking back and forth, showing the phase 2 and then phase 1. And there's also internally phase 0. And those are the different phases of operation for the 6502. You can see that in sync with my phase 2 output is my oscillator right there. And it is all working. You can see that it's counting up through the addresses. And now let's test to see if my reset button works. So you can see that it is cycling through the reset vector again. And now it's executing from EA, the EA page. Cool. So yeah, that is what I have set up currently for my 6502 project. It's just in free running mode. The next steps will be to add in some RAM and ROM, and hopefully some I/O and maybe serial. Thank you for watching.